Okay, so now we're going to be learning section 3.2, which is about writing expressions. I would title my notes Writing Expressions. So along with doing this section of notes, you also need to make a graphic organizer. The graphic organizer will be somewhere in your station to let you know what it should look like. But in this graphic organizer, you should make a foldable to talk about what are the keywords for addition, subtraction, multiplication, and division. These are very important to know because this is going to help you be able to figure out what operation you're using and when. This is not only going to help you in this section, but it will also help you when you're problem solving to figure out which operation you should use. So hopefully you've made your graphic organizer. I would glue it into your notebook before you start the rest of this section. So I'll give you some time to do that. You can pause the video at this time to do that and then play it to do the rest of the examples. All right, let's go over example 1, okay? Example 1 talks about it wants you to figure out what we want to write the phrase as an expression, okay? Remember, an expression does not have an equal sign, so you're just writing the phrase. So it says 8 fewer than 21. So you want to look and see, okay, what does fewer than mean? Okay, so I look in my graphic organizer, I see fewer than means subtraction, so it's 8 fewer than 21. It means I have 21 and I have 8 fewer. So therefore, this one's going to be 21 minus 8, okay? Many times students get this one mixed up because they think 8 minus 21 because that's the way it's read, but it's really fewer than 21, okay? The product of 30 and 9, well, if I look and see the keyword product of and look to see what word that means, I see product of means multiplication. So it's the product of 30 and 9. Okay, you can write it with parentheses, that means multiplication, or you can write it 30 times 9, either way, but I would like you to get in the habit of writing it this way since that's more algebraic. Okay? The next one, example 2, let's look at some more examples. Example 2 asks for similar to the first one. So 14 more than x. So how much do I have? I have x and I'm doing 14 more than that. So I have x, more than means 14. Means addition. So it's x plus 14. This one is one of the main ones that people get wrong because they put 14 plus x. Yes, because of the commutative property, 14 plus x and x plus 14 will be equal to the same number, but you have to write it as it's read, and it's saying 14 more than x. So in the next one, any number minus 75, it means I have any number and I'm subtracting 75. So this one's going to be y minus 75. In the last one, the quotient of 3 and a number z. Quotient means division, so I'm going to do the quotient of 3 divided by z. Now, when I do 3 and the number z in quotient, you go from left to right, and that's how it's written. Same thing with multiplication. I would recommend to pause the video at this time to do the on my own questions 1 through 6 on page 120. Let's look at example number 3. Example number 3 is a word problem. Okay, and let's read what this word problem says. It says the length of an interstate 90 from the west coast to the east coast is 153 miles more than 2 miles the length of the interstate 15 from southern California to northern Montana. Let m be the length of the interstate 15. Which expression can you use to represent the length of the interstate? So they put a lot of numbers in here to confuse you, all right? So the first number we have to look at is, let's look at the first sentence. The length of interstate 90 from the west coast to the east coast. Well, that doesn't really matter. None of that information really matters. So it's just telling you that the length of this is telling you the length of something, okay? So now let's look at what is the length. The length of Interstate 90, so we can say I-90, is 153.5 miles more than, so more than meaning that it's going to be plus 153.5, more than 2 times the length of Interstate 15. So it's going to be 2 times the length of Interstate 15 plus 153.5 is going to be Interstate 90. Let M be the length of Interstate 15. So because it tells me that the length of Interstate 15 is M, I'm going to change this to an M, the L to an M, okay? Because at first I substitute for an L for the length, but they told me specifically they wanted an M, okay? Write the expression that you can use to represent the length of Interstate 90. So there you go, 2M plus 153.5, and that's going to be letter A, okay? My recommendation is in your notes, I would write this whole example, and I would underline the key parts, circle the key words such as more than, times, and then I would underline M because you need to know what variable to use, and I would look at your question. Okay. Next, let's look at example number 4. Okay. Oops. Example number 4 says you plant a cypress tree that is 10 inches tall. Each year, its height increases by 15 inches. So we know at year 0, it's 10 inches tall because it told you that that's what it was planted by. Each year, its height increases by 15 years. So the first thing it says is make a table that shows the height of the tree for 4 years. So we have 0 years, 1 year, 2 year, 3 year, 4 year. I labeled the top of my paper or my table in years and inches so I know what I'm looking at. So I know in year 1 it increased by 15 inches. So I have to take 10, add 15, and I get 25. Then I know the next year I'm going to increase by another 15 inches. So I have to take 25, add 15, and I'm going to get 40. I add 15 again, I'm going to get 55, and I add 15 one more time, and I'm going to get 70. So after 4 years, it says that this cypress tree will grow 70 inches tall, or will be 70 inches tall. Okay? Then write the expression for the height after t years. So instead of inches, we're going to say inches equals, after t is the number of years. So therefore we have to substitute t for years. Okay? So write an expression. So we know we have a constant of 10. We notice that we start with 10 and we have to keep adding to it. Then each year we grow 15, okay? So we're going to add 15t because t represents the number of years. One way we can check this is by saying if I have 9 or let's say 2 years, I can substitute t equals 2, meaning 2 years. 10 plus 15 times 2 is going to be 10 plus 30, which is going to be 40. And that is exactly in the table what we have for 2 years. Okay? So we know that our equation is true. That is one way to check what you already know, logic, and check it with your expression. Now it asks, what's the height after 9 years? Yes, you can keep going on your table, 5 years, 6 years, 7 years, 8 years, 9 years, or you can go back to your expression that you just made and substitute for 9 years. So I'm actually going to erase this so I can substitute for 9 years. So now we're going to say t equals 9. T plus 15 times 9, okay, 10's a constant, it's always going to be 10. 15 times 9 is going to be 135. Let's double check that math. So 9 is 45. 9 times 1 is 9, plus 4 is 135. So plus 135, and it's saying after 9 years, it's going to be 145 inches. Hopefully, you understood everything in this lesson. If not, feel free to ask questions. At this time, I would go over on your own questions, number 7 and 8, and then go on to your practice. Hopefully this made everything clear. Have a great day.